Homework 6.2 part 1, I think. Anyways, it's writing models and modifying models. The exponential models below are the annual rate of increase. Find the monthly and quarterly rates. So hopefully you know there's 12 months in a year. So what we're going to do is we're going to convert the exponent into months. And that's really as simple as realizing that there's 12 months per year. So we're going to put that t over 12. The next move, and we know we're allowed to do this because we have a property, x to the a to the b is x to the ab. If you think about that property backwards, you can move parts of an exponent inside. So the next thing we're going to do is we're going to move that 1/12 to the inside. And we just have an exponent of t. There's some shortcuts to it, but they require memorization. So let's see what this is. I don't know why I'm typing all that in. You can tell it's a Monday. And it's about 1.0045. So 500 times 1.0045. And now it's just the t. And again, this is in months. Now, this piece right here lines up with 1 plus r. Okay? So 1 plus r must be equal to 1.0045, which means that your rate is 0.0045 per month. And of course, if you like percentages, that'd be 0.45%. Now, quarterly, it's the exact same process, except there's 4 quarters in a year. So we're just going to divide by 4. And we're going to do the same thing. We're going to move a piece of that exponent inside. Oops. Struggling this morning, forgive me. And we're going to see what that yields. $1.0135. So, again, this piece lines up with 1 plus r. So 1 plus the rate of interest must be equal to 1.0135, which means the rate of interest per quarter is 0.0135, or 1.35% per quarter. Don't be the kid who doesn't know how many quarters there are in a thing. You know, there's 4 quarters in a basketball game, there's 4 quarters in a football game. Alright, in 2012, see, no, I don't want to do that one. I don't want to do that one either. Even though that what I'm doing here is not technically correct, because the real formula is a little more intimidating. You decide to purchase a used truck for $16 grand. The terms of the loan are 6.9% interest compounded monthly for 5 years. What will your monthly payment be? Now, this is going to get us close. It'll give you enough to realize that you don't need to be borrowing money. So, our formula here is that the amount after time passes is the principal times 1 plus r over n to the nt. Now, I want to know what I own in 5 years. So, the time is 5. The amount in 5 years is the principal of $16,000. The rate of interest is 0.069, and that's sitting over n. And it's compounded monthly, so n is 12. It's raised to the nt. 12 it compounds 12 times 5 years. Then we go push some buttons. So we got our 16,000. 1 plus 0.069. She's sitting pretty over at 12, and the exponent here was 5 times 12, which is 60. $22,569.53. Now, I want to know what my monthly payment is. Well, I'm going to divide that by 60 because there's 60 months in a year. 5 times 12 again being 60, kids. And it's $376.16. Now, in the real world, it'd be a little less than that because as you make payments, the amount that you owe drops. It drops pretty slow initially, and then at the end of the loan, most of your payment is actually towards the principal. All right, moving forward. Let's do the pesticide one, because it's decay, and it would get asked. A lot of these would get asked, period. Be right back. A residual pesticide kills 26% of all pests every 17 hours. Now, this is definitely decay. We're killing. So the amount after time passes is the principal times 1 minus r to the t, but in this case, over 17. Now, your rate of return is 26%. Don't be the dum-dum who doesn't realize that that's 0.26. Don't be that kid. There's your initial population, 1 million. So the amount after time passes is the 1,000,000 cockroaches in your house, you poor kid. 1 minus 0.26 has always been 0.74. And then we'll raise the t over 17. So there's your model that describes the death of the cockroaches. A pesticide is something that kills pests. Even herbicides that kill plants are called pesticides. Anyways, after 4 days, how many cockroaches remain? All we're doing is replacing time with 4 days. Okay, that's the big thing. CPS a day is 4 hours. So we got to do 4 times 24, which is 96 hours, because this thing takes hours as its input. So the amount after 96 hours is 1,000,000 times our 0.74, and that's raised to the 96/17th power. Let's see what that is. There's still going to be several cockroaches left, but not many. 182,619. This is a life form. They get rounded up no matter what. So 182,619. All right, well, there'll only be one cockroach. I want this to the day, hour, minute, second. All right, so here, the amount after time passes is 1, and it's going to take a while. This is going to be a TI-84 problem. The unknown here is time, okay? This is going to be Y1, this is going to be my Y2. Let's see what kind of window adjustments we're going to have to make. Going to be several of them. I'm going to do zoom 6 even though it's useless. I'm going to have to look pretty far to the right. Remember, this is in hours, so let's go out 10 days. 24 hours in a day, 10 days is 240 hours. It's probably not right, but anyways. Let's go to window. Once my little calculator's done here. And you know what? Let's go out 20 days. 20 times 24 would be what, 480? So 20 days, and that's what I'm doing here. I'll write down whatever the final X-max adjustment is. If I don't see anything, that means I got to keep looking to the right, right? I didn't see anything. All right, let's double that. 960. That'd be 40 days. Hey, there it is. I want this to the day, hour, minute, second. So second, trace 5, enter, enter, enter. So we got 700.00567 hours. Alright, so I know that there's 24 hours in a day, right? So let's take our number, 700.00567 divided by 24. 29 perfect days. 29 days. Now I've still got this 1700ths of a day account to work with. I'm going to take away the 29 whole days. A day is exactly 24 hours, so times 24. 4 whole hours. 4 hours. Take that away. This 5,000th of a minute, roughly 6,000th of a minute, can we convert it to to seconds? I said that was hours. This 6,000th of an hour can be converted to minutes by multiplying by 60 because there's 60 minutes per hour. And it didn't happen, so there's not a whole minute, so I'm going to multiply by 60 again. And this is going to give me seconds, 20 seconds. Every year there's only like 3 or 4 kids who can ever do that conversion. Like, you ought to be able to convert to a useful thing. According to our mathematical model, can there ever really be no cockroaches? No, this was decay. And what does decay do? It flatlines at y equals 0. So no. There's 3 things that will survive nuclear winter: cockroaches, glitter, and rubber bouncy balls. Not doing that one. Alright, we got some quadratic formula ones. I'm going to do one of them. Of course, you should know the quadratic formula. I notice a lot of kids don't. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Don't forget the x equals. Now, in order to do this, you got to be in STD form here. You got to be set equal to a 0. We spent so much time talking about setting equals to zeros, but kids just don't get that. So anyways, we add 5 to both sides, shift it over whatever you want. A is 8, B is 6, and C is 5. So x equals, morning Mr. Hatcher, x equals negative b plus or minus square root b squared minus 4ac all over 2a. And then we do some math. Now this one's going to be imaginary. 6 squared is 36, and then you're taking away 160, which is negative 144. This is negative 6 plus or minus the square root of negative 144, both pieces sitting over 16. Now negative 6 over 16, both divisible by 2, that's negative 3/8. Your root of negative 144 is, first off, the imaginary root of a positive 144, and the positive root of 144 is 12i. I think I said that wrong. It's the root of 100 positive 144. So this piece becomes plus or minus 12i over 16, and both those are divisible by 4, right? So plus or minus 3/4 of I. And that's it. Alright, so I did 1, there's 12 total problems. I did 1, 2, 3, 4. I did a third of it. And in class, you'll probably ask for another 2 or 3, so that'll take you up to about 7/12. Yeah, you got it. You're welcome.